Let's have a look at some problems with locus exam type questions. So the first one, find the locus of the in the Argand diagram is satisfied by this one. Z times Z conjugate of Z minus 2 lots of the real part of Z is equal to 0. So Z times its conjugate we know is equal to x squared plus y squared. 2 lots of the real part of Z is 2 lots of Z, x. So if we rearrange it and start to get, so minus the 2x there, and we got plus y squared. To get what this looks like, well, we need to complete the square, so we add 1 there, x minus 1 all squared plus y squared equals 1. That's a circle. There's our circle there, center 1 0 with a radius of 1. So that's what our sketch would look like, that circle there. Hopefully you're happy with that. On the same diagram, draw the locus of the argument of Z is equal to pi on 4. Well, pi on 4 would be a 45-degree angle for pi on 4 there, and it's a ray that goes off in at an angle of 45 degrees there, pi on 4. So that's what that one would look like. Remember, not equal to the origin. So you can't put it there. So find the complex number that satisfies where both those. So really, we're looking at, well, what's that point going to be? You can see it meets there, but that's not going to be a point because it's not part of the origin. It's part of the circle meets there, but the ray doesn't. So to do that, well, let's get these two. We can know y is equal to x, so we can, because that would be the equation of the argument of Z is equal to pi on 4. That's the line there. It's equivalent. So we substitute y as being equal to x, expand out and simplify. We get 2x and x minus 1. Now x is equal to 0 or 1. We know we're going to reject 0 because it's not going to be equal to the point at the origin there. So if x is equal to 0, y is equal to x, so it must be 1. So there's our complex number that it meets up at, y at 1 plus I. That's our point there. Okay, the next question here. Sketch these loci. Well, remember, if we remember from our points, if we get the point Z1, 1 and I there, we're going to get a complex number that's going to be the perpendicular bisector of those two. So keep that in mind as you do that. There's our 2 points there, and this one's going to be perpendicular bisector. For the next one though, we've got Z times its conjugate, which is x squared plus y squared, and then minus I times the conjugate. So, and then we're assuming that Z is equal to x plus iy, so the conjugate would be x minus iy. We're multiplying it by I plus I times x plus iy. That's all equal to 0. So doing that, we expand that out, minus xy minus iy minus x plus xi ix, and minus y is equal to 0. Simplifies to that, the complex number parts go, and leaves us with x squared plus y squared plus minus 2y is equal to 0. Again, complete the square, and we get x squared plus y minus 1 all squared gives us equal to 1, which is a circle at 0, 1, or I if it's on the Argand diagram, and radius of 1. So that's why it's going through 2i, back at the origin there. Okay, question 3 here. We're told, this was a little bit harder, told that z's x plus iy and z minus I, z plus I is purely imaginary. So we want to equation the locus of the point representing z and show this on the Argand diagram. So we want the situation where that division is purely imaginary. So, well, let's simplify it. Put z x plus iy. So this would show it be x plus I times y minus 1 because it's a minus I there, and this would be x plus 1 times iy multiplied by the complex conjugate, so x plus I1 minus iy. That's going to give us a purely real number in the bottom, and then we get the x times the x plus 1, and then we do all our multiplication out. We're going to collect our real terms and collect our imaginary terms. Now, if this is going to be purely imaginary, remember that's going to be real on the bottom, so that part over that part would be an imaginary number. But this part over this part would be a real number. So that can't be 0. So the only thing that could be make this purely imaginary is if the real part there is equal to 0. So that's what we take here. So it's purely imaginary. What we've got there is going to be equal to 0 because you're not going to have a real part. You're just going to have the imaginary parts over that number. So what we've got, we expanded out. We've got x squared plus x plus y squared minus y is equal to 0. So we complete the square. We can see this is going to be a circle. X squared and y squared there. So we complete the squares there. The quarter can complete the part there. So we get x plus a half. Again, a quarter there. So we've had 2 quarters on the right hand side. And we're going to get y minus a half equal to 0. Y minus a half is all squared, and that's all equal to a half. So what does that look like? The locus is going to be a circle, because we said that, because we said x squared and y squared. We know it's going to be a circle. Our center is going to be minus a half and positive a half. And then the radius of that circle would be is the square root of that one, which is 1 on root 2. So there's our locus. That's our locus there. And putting on the Dargan diagram, we're at minus a half with a radius of 1 on root 2. So that's what we're looking at. It's a little bit tricky, but keep that in mind as you're going through and doing that. That's what it will start to look like. So again, doing all that algebra, not easy. And keep looking for this type of idea now. If it's purely imaginary, the real part would be 0.